Have you ever wondered how our brain can do so many different amazing things all at one time? If you're interested to learn more about the brain, stay tuned to Mysteries Mysteries. I am Mr. E, and we talk about all things mysterious in the world of psychology. Today, we get to talk about my favorite topic of all time, and that is the brain, the nervous system, and neurotransmitters. And so, I just want to talk a little bit about how our brain works. We're going to take just a couple of things. It's so weird how they're connected, but so I'll just give you a very broad understanding of a couple minor things about the brain. So, the brain, as many people know, is made up of billions of neurons. But what we might not know is that it's not the number of neurons that make us so smart. It's actually the number of neural connections that we make. And that's because of all these really cool grooves that we have in our brain. And why all those neural network, all those neurons being connected to each other are so important, because we have so many messages that are being sent from one neuron to hundreds of others at any split second that we're alive. So we're going to take just a couple of these situations today and walk you through them. There's a chemical that gets transmitted from one neuron to another neuron. And that chemical is called a neurotransmitter. Ultimately, just think neural brain, and neural is more nervous system, but neural brain messenger or transmitter messenger. So a neurotransmitter is a brain messenger ultimately, and it's passing messages along from one neuron to the next at any given moment. And we have a whole bunch of neurotransmitters, and depending on where these neurotransmitters are located, that's going to determine what they do. I'll give you a couple examples. So one neurotransmitter is called acetylcholine. And just so I'm not spitting all over the microphone the whole time, we'll just call it ACH from now on. So ACH is a neurotransmitter that does a whole bunch of different jobs. But I'll tell you about its diversity here, just with two jobs that it does. One job that it does when it is located in an area of our brain called the hippocampus, it is going to be in charge of our memory, which, okay, cool. And now if you think about it and you think, okay, so that's in charge of our memory, does that mean we have a whole lot of ACH and a whole lot of neurons working in the hippocampus? Could be. And you may think of the opposite. Well, my grandmother or my grandfather has dementia or Alzheimer's. Could that be related to the hippocampus and ACH? And in fact, it is. Low levels of ACH in an area of our brain, our midbrain called the hippocampus, the deterioration of neurons that make ACH is what actually causes Alzheimer's disease. So that's one piece of the puzzle. So what else can ACH do? Well, ACH is a neurotransmitter when it is located in the rest of our body, specifically traveling and hanging out at the ends of motor neurons. These are going to get wedged into skeletal muscle, and ACH is what actually helps our muscles to expand and contract. So you have in our brain, it helps with memory, and in our body, in our skeletal muscle, it helps with movement. So that's some diversity in ACH, right? So we have another neurotransmitter called dopamine, which I touched on in another episode related to schizophrenia. And so we're going to just talk a little bit about dopamine again. Dopamine does everything from learning and emotion to, once again, movement. And in a past episode, I mentioned that if we have too much schizophrenia, if we have too much schizophrenia, we're going to have a lot of hallucinations, delusions, and lack of emotion. Now, if we have a lot of, oh my goodness, if we have a lot of dopamine, specifically if we have a lot of dopamine receptors, people could end up with schizophrenia. If people have too little dopamine, they could end up with Parkinson's disease. One is related to emotion, one is related to movement. So there we have another very diverse example of how neurotransmitters can function in such incredibly fascinating ways. Now, we have these chemicals outside of our body that can invade the blood-brain barrier. And so we're going to talk a little bit about South American and Caribbean tribes right now. So have you ever seen, well, many of you have seen Raiders of the Lost Ark, right? And you see them shooting the blow darts shooting the arrows at Indiana Jones while he's running away, right? And you might have wondered, would those arrows kill him because they would like puncture his heart, or what would happen? Well, many South American tribes and one tribe in the Lesser Antilles in the Caribbean, they would make blow dart guns, or they would have bow and arrows. And on the tips of the darts, or on the tips of the arrows, they would put this chemical, which comes from a plant. This chemical is called curare, Curare. And curare, they would lace the tip of these darts or these blow darts, and when they would shoot it at their prey, the prey would become paralyzed. What? How does it become paralyzed? Because curare is known as an antagonist to acetylcholine. So acetylcholine is supposed to, come into my muscles and make my muscles move, right? ACH comes in and it goes into my muscles, and there's this crossing bridge and all this stuff happening. Long story short, hits these effector cells and it makes my arm constrict so I can move it, right? Curare comes along as an agonist, and what it does is it blocks ACH from working. So when it blocks ACH from working, it actually paralyzes those muscles. So when those tribes would shoot their blow darts or arrows at prey, they would actually be paralyzing their prey until they either suffocated or they killed them. And that's what they were trying to do with Indiana Jones. So if now you know a little bit about Indiana Jones and those blow darts, right? Okay, so most of us are not going to be shot by blow darts or arrows running through the fields and the jungles of South America, right? But many of us have had surgeries done. And in fact, and it's not done much anymore, curare was actually used in many wars, like including, I think may have started in the Korean War. But it was used as a local paralytic. So they would actually inject curare into, let's say, a lower limb. So a surgeon could do an operation on a soldier that was wounded in the leg, and that would actually paralyze that leg for a short period of time and allow the doctor to work on that soldier without the soldier feeling any pain. So that was a pretty interesting little connection there between curare and ACH. So now when we get to dopamine, we're going to talk specifically about schizophrenia. So schizophrenia is caused by too many dopamine receptor sites. And the receptor sites are what dopamine wants to latch onto, okay, for it to do its job. We need dopamine receptor sites because we need them for learning, for memory, for movement, and for healthy emotion. But there are times where people, 1 to 2% of the population, in fact, they have too many dopamine receptor sites. So if you've ever wondered how you treat somebody with a psychotic disorder like schizophrenia, or maybe an affective disorder like bipolar or major depression that turns into a psychotic break from reality, what they do is they give them antipsychotic medications like something like Clozaril or clozapine. And that comes along and that acts as an antagonist as well. That comes along and it blocks the receptor sites. So dopamine comes along, dopamine wants to find a receptor site, but it runs into the antipsychotic medication and it can't get to the receptor, thus lowering the impact of dopamine on that patient, on that person with schizophrenia or another psychotic disorder. And it's decreasing the impact of the antipsychotic, or excuse me, it's decreasing the impact of schizophrenia by the antipsychotic blocking dopamine's ability to be latched onto the receptor sites. So that's how antipsychotics work. Of course, because dopamine does so many other jobs, there can be other side effects from the blockage of those receptor sites. So I had mentioned I had an aunt with paranoid schizophrenia, and when she's on antipsychotics for years and years and years, that blocking of dopamine actually leads to Parkinsonian-like side effects. It's now like she almost doesn't have enough dopamine, so she has shaking and trembling similar to Parkinson's disease. And that is because of the antagonistic effect of the antipsychotic. So That's a little bit about science. I just touched on it very briefly, but if you're interested to learn more, make sure you make a comment or drop us an email, and we would love to share more with you. So let me know. But we just did a very brief overview of antagonists and neurotransmitters today. I hope you enjoyed it, and make sure you stay tuned for more. Follow us on Apple or on YouTube or on Spotify, anywhere that you can find podcasts. Make sure you give us a 5-star rating. That always helps us moving on up the ladder of availability. A big thank you to Bear Wade at Unify Agency for everything that he does. And again, follow us on TikTok, on Instagram, on whatever else you want to. All right. Hey, you guys have a great day. I'm Mr. E. This is Mysteries. See ya.